Ladies and gentlemen, welcome to the Moses Kotane Institute Friday lecture. We have our lectures on Friday where we invite experts in the industry to present lectures for us on specific contemporary topics. Today we are bringing you a lecture on 5G. We want to know what are the facts that are surrounding the 5G, and we have our guest lecturer, Dr. Moshe Masonta, who is coming from CSIR. Dr. Masonta is a research group leader under the Spectrum Access and Management Innovation at CSIR. Welcome, Dr. Masonta, and please can you take us through your lecture?
Thank you very much. Good afternoon, ladies and gentlemen. As I've already been introduced, my name is Moshe Masonta. I'm from the CSIR. The CSIR is one of the leading research councils in South Africa, where we'll be celebrating 75 years this year. Within the CSIR, we conduct multidisciplinary research. Under the ICT sector, our research is conducted within the Next Generation Enterprises and Institution cluster. That's where the group called Spectrum Access Management Innovation is hosted, and that's the group that I'm leading. Earlier this year, especially early April, we received a number of media questions from the media outlets asking us about to clarify the myths which were going around linking COVID-19 with 5G. We have been responding to those questions in a number of ways, but then later we realized let us put together, combine all those questions, put frequently asked questions answered on our website in order for the public to have an access and to see how actually all the answers that have been asked by previous the news outlet, and also to ensure that whatever questions they maybe have, maybe they can find answers there. So it's based on that article that this talk was established today, was initiated for today. So the outline of my talk, I will be talking about mobile networks and their evolution. What is 5G, the standardization efforts for 5G roadmap, 5G use cases, electromagnetic spectrum, facts about 5G and health safety, and the concluding summary. Mobile networks, they evolve almost every 10 years. So since their inception in 1980, we had a 1G, which was the first generation of mobile networks. That standard was mainly based on the AMPS. It was an American standard. And then the generation was an analog generation of the mobile communication. The frequencies around that operation of the 1G were up to 890 megahertz. And there were no specific requirements from the ITU for that generation, and it was there was no data exchange, it was only audio. In 1990s, 2G was introduced, the second generation. The most popular one in South Africa, it was GSM. It operated up to 1.9 gigahertz of spectrum band, and the data rates there, they were up to 336. The GSM or the 2G is the standard that introduced the digital communication and the short-term message system, like the texting. In the 2000, you can see that almost every 10 years, there's an evolution or there's a new standard which is being introduced. In the 2000s, there were a digital standard again, which was a 3G. 3G, number of standards which were under the 3G, we had UMTS, we had CDMA 2000, HSPDA, and the Evolution 1. The 3G operated on the frequency up to 2.1 gigahertz, and the data rates there, we are talking about 384 kilobits per second. It was through 3G that the IMT 2000 was introduced. IMT stands for International Mobile Telecommunication. It's defined by the International Telecommunication Union, which is an ITU, it's a United Nations body responsible for the telecommunication. The purpose of the ITU to start defining this IMT 2000 is to ensure that there is harmonization among networks across the world, so that when you go to from one region to another region, you don't have to change your handset. In 2010, 4G was introduced. 4G was another digital standard, now a move towards all IP communication. It introduced a mobile broadband, and the one which is we are most familiar with in South Africa is the LTE Advanced. The WiMAX, which is an IEEE standard, was also one of the 4G standard, but it did not take up as much as the LTE. The operating frequency, they were talking about 2.6 gigahertz. The data Theoretical data rate, we're talking about 1 gigabits per second. And the ITU requirements, they require the bandwidth of at least 100 megahertz and the very high frequency efficiency. In 2020 now, we are talking about 5G. 5G is another enhancement of the mobile communication. But as we can see here on why, when we start defining the 5G, it brings a very fundamental change to support new emerging capabilities. It may not be seen as another evolution from 4G to 5G, but as a standard which is introducing completely a new paradigm shift in the communication. It is for this reason that the ITUR has defined the minimum technical performance requirements. It is through those performance requirements are set there to allow the standardization bodies like the IEEE, the European ones, the Japanese and the Chinese standardization formulation bodies to meet the minimum requirements for them or their standard to be approved as 5G. That is how the process goes. So the requirements for the 5G, there's a triangle which is normally used. They are defined within the 3 use cases. So the first use case, we're talking about enhanced mobile broadband. Here we're talking about speeds at 20 gigabits per second. We are talking for uplink, for downlink about 10 gigabits per second. We're talking about the mobility. It must support the mobility of about 500 kilometers per second, like in the bullet trains. You can still communicate without braking. The second requirement there is a massive machine type communication, MMTC. Here we're talking about the density of the devices. About 1 million devices per square kilometers should be supported or connected by the 5G network. And the third one is the ultra reliable and low latency communication. Here we talk about minimum user plane latency of 1 millisecond. So that's how the 5G is revolutionizing and changing the way we communicate using mobile communication. When we talk about the self-driving cars, that's where we need ultra reliable and low latency communication. You don't need a delay in decision making when the car is driving itself. From the machine type, we're talking about the smart cities, whereby many devices, machine to machine, they will be communicating among themselves. There will still be can be voice over IP. So that's how the 5G is going to be seen going forward. So here we're talking about the roadmap towards the deployment of 5G. For every standard, communication standard, there is research which takes place before the standard is finally introduced. So for the 5G, the research on 5G started almost 10 years ago. We are now towards the deployment of the standard. The current deployments, we call them non-standalone 5G, meaning it's not yet fully new radio 5G. And we are expecting the ITUR to complete the development of radio interface recommendation by November 2020. Then from there, we expect a full-scale deployment of 5G. Some of the use cases of 5G, here I'm sharing the picture which comes from a paper that CSIR authored with Erik Eriksen in 2018. Is titled "Making 5G a Reality for Africa." Here we're looking at the 5G use cases, especially for developing countries like South Africa. If you can look at the diagram, there are some functionalities which are already being offered, like when you talk about enhanced mobile broadband, automation, automotive, manufacturing, energy and utilities, as well as healthcare. As we move from current where we are with the 4G towards the full 5G experience, that's where you start going to experience more of the 5G benefits. For example, for healthcare, once the 5G is deployed, we expect remote operations. We expect autonomous control on the automotive sector. Another important component on the 5G is electromagnetic spectrum. Electromagnetic spectrum is divided into what we call, is classified in what we call ionization radiation and non-ionization radiation. The radio frequency spectrum are within the non-ionization radiation, meaning they do not transmit or produce more energy that can cause damage to the human being. The ionization radiation, these are the ones which are used for the X-ray. When you go for an X-ray, those radiations which are used because they can penetrate through the human being. So the current deployment of 5G, as you can see from the diagram, they are at what we call 3.5 gigahertz band. So this is the band which is currently being used by other operating, mobile systems like the Wi-Fi. Wi-Fi is already operating both at the 2.4 gigahertz as well as the 5 gigahertz band. So there is no, from the best of our knowledge, and as we can see based on the experience which over the past 30 years of using the mobile operation, it is about as safe as all previous generation of cellular technologies. That's how we can say the sub-gigahertz. But when you go to the future deployments at millimeter wave, we are talking about frequencies which are more higher, like we are talking about 26, we are talking about up to 95 gigahertz of spectrum. Those are the ones which we call millimeter wave. But still, those frequencies are still way below the ionization radiation. Here on the millimeter wave, the World Health Organization has found that these frequencies still do not significantly penetrate beyond the human skin. So coming to the facts about 5G and health, number one, the power levels between base station and mobile devices are strictly regulated. It's very important to know that it is regulated. So mobile phones should be tested and certified for compliance to health and safety regulations before they can be used. So there is some of you may see on any device which is emitting RF, it has a sticker from ICASA which calls type-approved. So that's the regulation which come in to ensure that there's safety there. Internationally, there is a body called the ICNIRP, is for non-ionization regulation for protection of the human beings. That one also, they regulate the energy that can be emitted with their mobile communication to ensure that the lives of the people are saved. So that's the first thing. There's no way that the mobile communication, which we know currently, could be taken to the market before the safety is taken into account. Number two, the current 5G networks radio frequency emission differ very little from their predecessors. So the World Health Organization has concluded that the radio frequency electromagnetic field radiation is possibly carcinogenic to humans, meaning they can't cause cancer. Number three, no large-scale 5G rollouts have taken place as yet, and the most areas in which coronavirus victims are found do not have a 5G rollout currently. So the report by the Global Mobile Supply Association, which was issued in April 2020, has shown that only 12% of the 4G operators have deployed 5G services. That is a small fraction. The fourth one, there is no credible scientific evidence that shows a link between SARS-CoV-2 virus and mobile phone signals. So the signals or the frequencies for 5G do not significantly penetrate human skins. So in conclusion, development and implementation of 5G is not close to its peak yet. We are still to see 5G and it delivering even more opportunities than its predecessors. And it's expected to even to give us or to give birth to new services which we have not seen before. Just like its predecessors, 5G is closely regulated to ensure that users can safely enjoy its benefits. However, research to maximize any public concerns about radio frequency emission and radiation from mobile communication systems in the millimeter wave band is still welcome. CSR's position is that no plausible link between 5G and the coronavirus could be established. So we disputed the myths which were published and were circulating in all the media outlet. Consumers are encouraged to question conspiracy theories rather than accepting their inherent outcome of promoting fear and uncertainty. From the CSR side, there's ongoing and planned R&D work on 5G. The first one is the 5G core network testbed that we have established within the CSR. This was funded by the Department of Science and Engineering. Science and Technology, or now it's Science and Innovation, yeah. Then the other work that we are doing also there, we are putting together a platform for the outdoor and indoor radio access network research for broadband and IoT research. And the investigation on any open research questions on the health effects of millimeter wave are also being investigated. We are not turning a blind eye on this, what is happening out there. We are investigating them, especially on the millimeter wave. But currently, the deployment of 5G, they are within the bands which are being used for other mobile communications. Thank you very much. Questions and answers.
Thank you so much, Doctor. Can you mute your mic, please? All right. Thank you so much. We have quite a string of questions that have been asked by the attendees on Teams, but I'll take them group by group, maybe 3 sections. The first one is coming from Tabisha. Tabisha is saying, can you explain what 5G is to a 5-year-old? How would you explain what 5G is to a 5-year-old? Okay, and then the second question is 5G better than Wi-Fi? Is 5G better than fiber and Wi-Fi? And also, why does it need fiber optic? That is coming from Duduzani Zondi. The third one is, when do we need to anticipate the release of spectrum for 5G? That is coming from Wayne Jenica. Eli Tlubata is asking the question, what are the economic factors on adaptation of 5G? In other words, will it require less infrastructure as compared to broadband? In short, is it more expensive infrastructure that is required? And Chapisha is asking a question, how can we interested academics get involved in 5G research? And then let me ask the last set so that you can cover all of them at once. Emmanuel is asking quite a number of questions. The first one being, there are indicators that 5G signals are not receivable inside buildings. And he wants to know if one has to go very close to the transmitting antenna for reception. Secondly, he is asking, does he need to change his current device in order to access 5G? And if so, what would be the cost? Or can he just ask the network provider to switch from 4G to 5G? And how long will it take before the country takes or use the 5G as a coverage country-wise? And at what investment is required for 5G? All of those questions are coming from Emmanuel. And then we have Tobelani, who would like to know, how will 5G change our lives? How will 5G change our lives? So those are the questions, Doctor, if you can please answer them. Please unmute your mic.
Thank you very much for interesting questions. Can I start anyway, or should I answer them in order?
You can answer in any order that you wish to answer them.
Okay, so how will 5G change our lives? We are talking about the fourth, I think this comes from Tobelani. We are talking about the fourth industrial revolution. So the fourth industrial revolution, it will require a lot of devices connected amongst themselves. And it also, while I attended the Moses Kotane lecture last week, whereby it was also clarified that a fourth industrial revolution is not going to take jobs, but create more jobs. So 5G is going to enable those technologies, those fourth industrialization technologies. So it's going to improve our lives. It's going to ensure that for people who are now not connected or having connectivity issues or poor quality of the connection in their areas, once you get connected to the 5G, you get high broadband, you are able to do your schoolwork and other medical related consultation without even having to go to the doctor. So that's how 5G will improve our life. When it comes to Emmanuel, it's important to note that 5G is not yet fully deployed in the country, and is deployed currently and branded as 5G, I would say is sort of an evolution towards 5G, right? We can even call it 4.5, because as I've indicated in the slides, the 5G deployment, full 5G new radio deployment is still to be expected in the Q4 of this year or Q1 of 2021. Meaning what he may be saying when he say he can't get the signal of 5G, he may be talking about non-standalone 5G, and of which if there's no powerful signal there may be other different ways of communicating with the mobile operator, the service provider, to assist in enhancing that the connectivity. But when it comes to the devices, currently there are no widespread devices of 5G. So the device that you may be using, yes, indeed is right. You will have to get a new device. So once his area or wherever it is, there's a 5G coverage, you will need a different device which is 5G compliant. It's just like when we had the 2G devices, and then the 3G came, we had to upgrade our devices and get a new device. So the current device that we are having, we cannot just switch it into 4G. We have to buy a new device. How long will the deployment take for countrywide? Just like with 4G, it's something which depends on the mobile operators, their strategy and their mechanism that they may use, their business model. Some they may use the network sharing, some may use roaming arrangement to ensure that they provide that connectivity. But again, it's important to know that when we talk about millimeter wave for 5G, we're talking about the frequencies which do not travel further distances. So where millimeter waves are expected to be deployed, we are talking about the areas, the densely populated areas, like the sport arena. That's where we can see this. So for the countrywide deployment of 5G, that is another question, which whether the mobile operators, they will have that investment to do so, or still with the 4G coverage that people are having, they can still access or enjoy the benefits which are provided with the mobile broadband. There was a question about the infrastructure. The infrastructure expenses. Yes, there will be, like I said, it's a 5G. It's not just a simple evolution from the previous generation. It's a paradigm shift. So the way it is structured, it will definitely require some bit of investment. For example, the base station that was used for 3G or 4G, it may not be sufficient to cover the same area when we come to 5G, especially the millimeter wave. So we may need more small cells which are deployed somewhere in the streets to ensure the coverage is improved. And with regards to the difference between fiber and Wi-Fi and 5G, and why 5G requires optic fiber. What happens is 4G, 3G, 2G, all of them, they still require optic fiber for what we call backhaul. So from the base station to the data center or to the core network of the mobile operator, you need pipes which will provide very high broadband. So that's why you use fiber. So the fiber is from the base station back to the core network. So even that's the reason why 5G will also require the fiber. It will require more fiber just for the broadband, but for the access, it will still be wireless. When we compare it to Wi-Fi, it will be different because we are talking here about a very wide bandwidth for 5G, and we are talking about other elements, the requirements which you spoke about, the enhanced mobile broadband, the massive machine type communication, the ultra low and reliable communication. So those features or those functionalities are not yet there, or they are not defined for the Wi-Fi. So that's the difference between those two. For a 5-year-old, how can you explain 5G or define 5G? For a 5-year-old, it just for me, it's an interesting question. I would say it's another way of wireless communication, which is more better than 4G and allows the variety of services without needing a cable. to connect, because anyway, most of them, the kids, the 5-year-olds, they do not know the ADSL, etc. So yeah, it's just a wireless communication system which provide the high-speed communication equivalent or almost equal to what fiber could provide. I'm not sure whether the 5-year will understand, but that's how best I think we can answer that. When anticipated the release of spectrum? Yes, this is the question about the release of spectrum. Currently, under the COVID-19 state of disaster regulations, the ICASA has released emergency spectrum, what they call emergency spectrum. So on that emergency spectrum, there is a bandwidth, or the band on the 3.5 gigahertz, which is allocated, and we've heard that Vodacom was among those operators, the first operators who got that spectrum to deploy their 5G. Right, so that's a temporary spectrum for that. But when we look at other spectrum to be released for 5G, that is the process which the regulator is looking into. There is a policy directive from the Minister of Communication, which was issued late last year, to say there should be a study by the regulator to see on the high demand spectrum, when will it be released. So we just have to follow that. As to when specifically, I do not have those timelines. In addition to that, for the millimeter wave spectrum, we know that there is ITU, World Radio Communication Conference. That's where these spectrums are being discussed and agreed upon, taking into account the way the spectrum is being used in other countries to ensure that harmonization I spoke about. So even that, there may be additional trials and testing of those harmonization and the usage of spectrum in the millimeter wave. But into a country as to when will such a spectrum be released, it's something which we should expect in the next few years. I think I've okay, how to be involved in the 5G research as the academic. Okay, obviously every academic institution which has the research and development part, or the research part where they will have postgraduate students, the masters and the PhDs, they will have their program, they will have their research programs and their area of expertise. So some they will focus on other ways of communication or other technologies. Some will focus on mobile. So it depends on what is your strategy. If your strategy is about working towards mobile communication, then we are, from the CSR side, we are very much open and looking forward to have collaboration with academia and industry when it comes to research in 5G. Thank you very much. I think I covered all the questions.
All right, thank you very much, Doctor. I think we have covered all the questions, and thank you for coming to provide this lecture, very specific lecture on 5G, which we really appreciate. And we have run out of time, but I think at this point in time, we will end it there. The video will be uploaded onto YouTube or in Moses Kotane Facebook page, so that those that didn't get a chance to view to attend the lecture can still access this information. Thank you very much, Doctor, for this wonderful information, and we really appreciate it. Thank you.
Thank you very much.
All right, bye.
Bye.